Welcome back, everybody. In this video, we're going to be taking a look at our first video when it comes to DMVPN, or Dynamic Multipoint VPNs. And what we're going to be doing is taking a look at what we need to understand about how DMVPN actually works. So we're going to cover a little bit about the Next Hop Resolution Protocol, or NHRP, some of the different terms that we have to understand from a operations perspective, and stuff like that. What we're going to be focusing on primarily in these few initial videos is understanding how DMVPN works and why NHRP is really necessary. And then we'll take it to the next level, which is going to be adding things like encryption to it. So a lot of the technologies and techniques that we're going to be taking a look at are going to be revolving around the operations of how the protocol actually works. So once we understand those variables and things like that, then we'll be in really good shape to dive into the actual implementation of the technology, which is actually really easy to work with. But in terms of how it operates and stuff like that, we really need to understand those underlying bits so we can dive into the actual underworkings and get everything operational. We're going to be looking at a lot of different variations, and if at any point you're looking for a command that I typed in or anything like that, be sure to check out the DMVPN portion of Simplified Networking, where we can go and the initial actual configurations that I'm going through right now have already been tested out, and the outputs are there. So the videos here are designed to definitely be more involved for the deeper explanation, show commands, stuff like that, and go from there. So without any further ado, let's go ahead and understand some of the underlying bits of what we're trying to accomplish here. So let me go ahead and pull up my pen tool, and we'll talk a little bit about how DMVPN works under the hood. So my pen tool is not behaving, so I will go ahead and relaunch that. So just bear with me for just a moment, folks. So when we go ahead and set this up, we're looking at operationally understanding how DMVPN works from the overarching aspect of what it's doing. So traditionally speaking, what we're looking for when it comes to DMVPN is going to be a way of moving away from the static GRE tunnel. So traditionally speaking, you would have a GRE tunnel that would be set up between these locations, and you'd have another one that would be set up from here to here, and then you'd have another one that would be set up from here to here, and things like that. So you'd have three separate tunnels, right? Well, that would work, but for three locations, not that big of a deal. But what happens if you had other locations way over here? You know, to keep drawing circles, right? Well, then you would have to have tunnels to like this. Well, that's really not the upper scaling issue per se. Normally, DMVPN is tied to IPsec. And IPsec is used to encrypt the traffic that's riding over the tunnel. So this would be an enhancement to what would normally be a site-to-site VPN, whether it's a crypto map-based VPN, whether it's a crypto profile or a static virtual tunnel or what have you. Those are the issues that we're going to run into, where every one of these tunnels that we've drawn here are going to be /30s normally, and that's going to be a number one. That's going to be a subnetting issue, and then you're going to have at least one. You're going to have IPsec SAs, the actual security associations, that's actually going to be encrypting the data. So you got a lot of overhead as well. So what was developed was the NHRP, or Next Hop Resolution Protocol. So for those of you that have been in networking for a little while, you've probably heard of ARP, or the Address Resolution Protocol, which was a design to make layer 2 to layer 3 mappings come to life. The idea was, if I'm connected to a layer 2 environment and I have an IP address of .34, for example, here. That's actually supposed to be a 3. You have 34 here, and you got .3 here, and you got .4 here. Well, what's going to end up happening is they're attached to the same common subnet, VLAN 101. Well, in this particular case, what you're going to run into is I need to be able to figure out what layer 2 address gets me to .34, right? So you would do an ARP, and then this guy would respond with a ARP reply saying, okay, my MAC address is A, and then the switch would say, okay, A is located on this port, B is over here, and C is over here, for example. So then the switch would know intelligently where to forward the traffic. Well, that's ARP, right? Well, NHRP is very similar, but what you're trying to bind is a layer 3 IP to a layer 3 IP. Well, what do you mean layer 3 to layer 3? Well, what you're trying to bind is the public address right here to whatever the tunnel IP is at the tunnel interface level. So that could be a 10.1.1.22, for example. So you're trying to bind 122.0.0.22 to 10.1.1.2. So you're doing an NBMA, or the non-broadcast multi-access mapping. So it's an NBMA to VPN, or private address. So your NBMA address is going to be 122.0.0.22 to 10.1.1.22. Now the correlation that comes into play here is that now that we have this binding, we know that when traffic is received in on this interface, that when it's NHRP, that we know that it's going to the tunnel. So that's how the software is written in the code. Now, when we go to do this, the hub, which is going to be iOS 22 for this example, is going to be configured to receive any of these mappings that are statically set up on the spokes. So the hub is very dynamic, the spokes are very static. So I drew the little S next to the spoke to infer that it's a static configuration. So what's actually going to be happening is, if we look at this from the perspective of a cloud, we're going to have connections coming down from all these locations connecting to this cloud, right? So we're going to have a total of 4 members of this cloud. iOS 22 being the hub, and then iOS 24 being the spoke, CSR 11 being a spoke, and iOS 25 being a spoke. Now, this will end up nailing up, you'll end up getting these static connections that are going to be nailed up from the spokes down to the hub. Now, what the benefit of this is going to be, now mind you, is there's no routing enabled yet at this point, and there's no IPsec involved yet. So we're just talking about NHRP from the respects of how the spokes will register with the hubs. That's it, nothing more than that. Now, what we can do as we're going through this process is we can add these capabilities. So DMVPN on its own is simply a routing technique, nothing more, nothing less. You go and you create a GRE tunnel on the hubs and spokes, but one of the key differentiators is you use the tunnel mode of GRE multipoint. You don't use the tunnel mode of GRE IP. By doing that, you're removing the tunnel destination command from being needed. You still need a tunnel source. That doesn't change. But you're enabling the GRE multipoint. So what you're basically doing is you're using the NBMA address, as long as the routers know how to figure out where to go inside of the network, which they do because they're all internet connected. Because they know how to get all of that connected, then it's just a matter of going through and forming the connections. So on all of these routers, iOS 22, iOS 24, iOS 25, and CSR 11, they all have a default route pointing to the internet. So now this is a simulated internet inside of my lab, obviously, but beyond that, they have internet connections, and all the IP addressing has been laid out for your, if you want to mimic this in the lab. So we have all of that laid out. Now, what's going to end up happening is, in cases where we have devices that are connected and everything is working, we're going to need a couple of NHRP commands. The commands we're going to be looking at is going to be the network ID. The network ID is going to be set to 1. We're going to be looking at an authentication because we want to make sure that if there is any, I'll just write auth. If there is any packets that are intercepted, that we want to make sure that they're hashed and that people aren't just going, oh, this guy's running NHRP, this guy's running DMVPN, so let's just try to join their network and stuff like that. So we're going to run authentication, and we're going to set it up to where they're going to be able to form a connection with each other. Now, once that's done and we have the NHRP config, then we can go to the next step, and that's going to be enabling routing. Routing is technically the second step. Once you get the routing up and running, then you're going to be using the routing protocol to figure out all of the who's peered to who and things like that. Now, DMVPN actually is made up of 3 different phases. You have phase 1, which is going to be all communication from anything to anything is going to be going through the hub. So this is going to be hub-only communication. So that means if you want spoke to spoke connectivity, it's going to have to go spoke to hub to spoke communication. So if you want to talk from iOS 33 to switch 19, they need to go over the tunnel through 22, then back down to switch 19. Now, is that going to be a legit scenario? It very well could be. We could need to telnet into switch 19 for whatever reason. The other variation of this is going to be phase 2, which phase 2 is going to allow us to move into spoke to spoke on demand. Now, the logic here is we are doing a routing protocol. I'll just put in proto mod. Now, with EIGRP, and let me go ahead and just erase some of this stuff down here so that it's not in the way. With EIGRP, you are going to go ahead and you're going to disable, so EIGRP, it's going to be disable split horizon at the tunnel level. With OSPF, you're going to move to the network type of broadcast. And we're not really going to play with any of the other variations of it, but with, say, BGP, you're going to do route reflection. We'll take a look at some of these different variations as we're going along, just so you guys can see the different flavors. Because simply playing with just one routing protocol is, I mean, it does the job. The most common are going to be EIGRP and BGP. Those are the 2 most common. So we're going to take a look at not only how the connections work with just a normal setup, with no encryption, just doing some routing and stuff like that, so we can see the details of what's actually happening, but then we'll add other routing protocols to see what the differences look like. And then once we have a good idea of how that comes into play, then we can add IPsec, which is technically the 3rd step in the process. Now, there is a 3rd variation that's called phase 3. Now, phase 3 happens to be my favorite of all of them because it gives us the most flexibility. Now, what's going to end up happening here when we talk about phase 3 is a little bit different than phase 2. Now, phase 2 is going to allow us to go spoke to spoke, but what's happening is we're basically telling the hub, you're no longer going to be playing inside of the realm of what we're doing. So when there's a routing update or whatever, we're going to tell the routing protocol from the hub down to the spoke, instead of pointing yourself to me for a route towards switch 19, point yourself directly to who you're trying to connect to. So in other words, if iOS 33 wanted to talk to switch 19, iOS 24 is going to point to CSR 11 as the next hop versus iOS 22 for the next hop, and then rely on iOS 22 to forward the traffic. Because we don't want to go directly through the hub. We want to go directly to the next hop. So the next hop is going to be modified, but this is, again, it's going to be a routing protocol modification. Phase 3, which is typically the most common design, and one thing that I want to highlight real quick before I dive into that, all three are technically valid. Depends on what you are looking to do from an operations perspective. I've worked with customers that have wanted phase one because they don't want spoke-to-spoke communication. They strictly want stuff to go through the hub, and then sometimes it's going out to the internet through the hub. And I've had other customers that are like, sure, we want site-to-site communication because our branches need to be able to talk to each other, regardless of what that particular customer's industry is, whether it's healthcare or finance or manufacturing. They have to me, being an architect and an engineer, I don't care what their industry is. I need to be able to meet the business requirements using the technology, and the technology has a flexibility. So phase one is going to be through the hub only, which is very good for security and types of environments where you might have like PCI or SOX or some other type of governance or compliance that you may need to meet. Phase two, it gave us some flexibility to where we're not having to rely on anything, but we're using the routing protocol to make the modifications for us. Now phase three is going to be an NHRP modification. Okay, so this is a mod. Now on the hub, it's the redirect command. And on the spoke, it is going to be the shortcut. Now what's going to happen is you're going to have a request and a resolution process come into play here. And what's happening here is, in the event that iOS 33 wants to talk to Switch 19, or let's say iOS 33 needs to SSH into Nexus 20 up in Data Center 2, regardless of the situation, what's going to happen is iOS 33 is going to send the traffic to iOS 24. 24 is going to have a next hop of iOS 22. Now, because he's got the next hop of iOS 22, he goes, 22 says, oh, well, you're not trying to send traffic to me, you're trying to send traffic over to iOS 25. Because iOS 22 is the hub, he knows about iOS 25. So he's going to send a mapping message over to 25 saying, hey, 25, I have a request from 24 saying I need to know what your address is. So there's going to be a message that goes back to 22. 22 is then going to forward that down as a resolution, and 24 is going to get a Ceph update in the layer 2 portion of things to point towards the IP address of 25. So he's going to get that. And once the next hop is updated, that's going to be what they refer to as the next hop override. So you're not trying to point yourself back to the hub, you're trying to point yourself to the spoke, right? So what's going to end up happening is oftentimes inside of the routing protocol, in the routing table, you're going to see the percent sign. The percent sign is going to say next hop override. We're going to point the traffic towards the destination that you're trying to get to, and that's going to be phase 3. So that's going to be the basics to how DMVPN comes into play and what the operations are for DMVPN from how it actually comes into play. Now, mind you, everything that I'm talking about, none of this at all has to do with IPsec. And this is routing protocol flexibility as well. So you can do all of these things without any type of encryption. So I've done this quite a bit inside of the over MPLS environments, where encryption is not necessary because it's a private connection, right? It's only when you're going over the internet is when it becomes, when privacy is necessary. So that brings me to my next stage. So the process that we're going to go through here, and I should have brought this up earlier in the video, but what we're going to be taking a look at in our flow is going to be understanding the initial setup, or IS. So we're going to set up DMVPN to understand exactly what we're going to be covering and how it's going to go flow. And then we're going to go ahead and focus on phase 1. Phase 1 is pretty simple. And you're going to have spoke, hub, spoke communication, spoke to hub. That's it. No spoke communication, at least initially. If you want communication from the hub, or it's from spoke to spoke, you need to go phase 2. Okay? That's simple as that is. Phase 2 is going to be, again, it's going to be a routing protocol modification. So EIGRP, it's going to be disabling split horizon. With BGP, it's going to be route reflection. With OSPF, it's going to be the broadcast command. And then in phase 3, and only in phase 3, we'll go over to the redirect command and the shortcut on the hub and the spoke, as we previously mentioned. Now, once all this is done, this is all the everything that you need to know about DMVPN from an operational perspective. Now, there are enhancements like clustering and prioritization and dual hub, dual cloud, dual hub, single cloud. We'll take a look at those as well. So then it will have the dual hub, single cloud. We'll take a look at the dual hub, dual cloud, and how that can come into play. And then we'll take a look at how the clustering comes into play and things like that, and prioritization. Then once all of that is covered, and that's going to be without any enhancements to with cryptography or IPsec, then we can dive into IPsec and take a look at how it comes into play. Because we don't need IPsec at all. We could just do this straight over MPLS if we wanted to, and that would work just fine. That's going to be where we dive into that. Then it gets a little bit more interesting. Then we have to dive into the VRF aware portions of that. And the VRF aware portions can be done without IPsec as well. I've done it plenty of times. Once we get that, then we get into some of the weeds, and we get into running MPLS over DMVPN. You might say, why would you ever do that? Because you can. So this could be what they refer to as 2547 over DMVPN. We'll take a look at how that comes into play. It's an advanced concept, but it can be done. And for those of you that are studying for the upcoming CCIE Enterprise Infrastructure Certification, that would be something you would want to know. And now, mind you, with all of these, IPsec should be used, and we'll be taking a look at those variations as well. We'll take a look at the VRF aware capabilities as well. But I'm not looking at encryption right away. I'm looking at just the operations of the protocol and how it goes into play. Then, once we have all that done, then we have the dynamic hub, or let's say DHCP, or a dynamic address at the spoke side. We will do DHCP on the tunnel interface for the spokes, because that's definitely an option. And then, last but certainly not least, we'll look at it where this guy is running NAT, and we need a NAT outbound. So this guy right here is the tunnel, so this is your spoke, and this guy needs to form a connection back to iOS 22. So we'll do NAT aware as well, or dealing with NAT NAT traversal. So that's going to be the other variation we're going to take a look at. So we have a lot to cover in this section, and the beautiful thing about it is you guys get to go over to Simplified Networking and check out anything that I'm talking about. We'll have already demoed it and stuff like that. The YouTube video will not be available until it's been demoed on the site. So as I'm going through this, I will be adding the variations to the configuration. So you'll be able to reference this, and the topology is not going to change. So what's cool about this, and I know this is a DMVPN video, but my goal is to take this variation of what we're doing and then move this over to Flex VPN in the future. So we'll be able to take a look at how that comes into play with Flex VPN and all of those capabilities. And I'll be able to do all of that. So the topology might change a little bit because of the fact of what we're going to be dealing with in terms of the adding ASAs and stuff like that into play with Flex VPN, because DMVPN is not supported on that. But those are just some of the advanced capabilities we're going to be taking a look at as we're going along. So this video will be embedded inside of the web page on the site, so you guys will be able to take a look at that. So we're 25 minutes in, so I don't want to take any more time than I already have on this initial video. In the next video, we're going to go ahead and take a look at the actual implementation of DMVPN on the routers as it's based off of the config page and stuff like that. Until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.